Automatic Addison.
In this tutorial, we will create a ROS2 package. In ROS2, a package is a folder. That's it, just a folder that contains specific files related to specific functionality or a component of a robotic system. So this folder includes things like the actual code that makes the package do what it's supposed to do, files that help define how the code should be started and set up, and any special message types or configurations the package needs to run. ROS2 packages are designed to perform specific jobs. For example, consider a robot that needs to determine its position and orientation within a given environment. You could create a package called localization that handles this specific task. And that package would contain the code, a README file, and any custom messages the package needs to share localization with other parts of the robot's software. So this modular approach makes it easier to maintain, debug, and improve the capabilities of your robot because all the specific functionality is contained in modular packages. So it allows you to reuse the packages across different projects or robots that require similar features. Now, for a real-world robotics project, you will combine all these packages together to create a complete robotic application that performs various tasks and functions. So enough chit-chat. Here at Automatic Addison, we learn by doing. So let's create our first ROS2 package. Let's create our first ROS2 package. Open a terminal window. And let's move to our workspace. So we did cd ROS2 _WS / and then cd src. So best practice is to create your ROS2 packages inside your source directory, src by convention. Now let's run the ROS2 command for creating our first package. And we do that, we do ROS2 pkg create and then build, 2 hyphens there, and then build type ament cmake. This is for a C++ ROS2 package, which I prefer for most applications because C++ is a Swiss Army knife and it runs really fast compared to Python. So license, and we're going to use the Apache license right here on our software. You can Wikipedia that, understand what that entails, but I like to use Apache 2.0, which allows you to modify, anyone to modify, distribute the code as they please. And let's call this package ROS2 fundamentals examples. All right, our package is created just like that. So that command created a new ROS2 package named ROS2 fundamentals examples. We could have called our package any name, but I chose to call it ROS2 fundamental examples. And let's clear and let's see it in there in all its glory. ROS2 fundamentals examples. So what did we do in that command we had earlier? So build type ament cmake specifies that the package should use the ament cmake build system. That's the recommended build system for ROS2 packages written in C++. Think of it as a set of instructions and tools that help you put together all the pieces of your ROS2 package, making sure everything is properly compiled, linked, and ready to run. And again, the license Apache 2.0 right here that sets the license of the package to Apache license 2.0. Again, that's a license that has minimal restrictions on how others can use, modify, and distribute the software. Now, let's do Control C. Let's clear our terminal. And to build our package, you navigate to the root of the workspace. So we're going to do cd ... We're now in the root of the workspace, and we need to build. And to build in ROS2, you type colcon build, COLCON BUILD. And that's it. You built your package. So now let's see if our new package is recognized by ROS2. So open a new window, or we could have also sourced our bash if you followed my earlier tutorial. Okay. Source the bash RC, but let's just open up a new terminal like I did and type ROS2 pkg list so we can see all the packages for ROS2 that are installed on our system. And let's search for our new package. We called it ROS2 Fundamentals Examples. Gotta be there. There we go. In all its glory, right there. Our new package is now registered in the ROS2 system. Okay, what I like to do, because we're going to be running colcon build all the time when you're building robotics code, I like to add it as an alias to the bash RC file. So to do that, you do echo quotes alias build. We're going to add an alias called build. And when you press the alias, let's do equals single quotes, it's going to run this command. It's going to go to the root of your workspace. Colcon build. Tilde dot bash rc and source dot bash rc. Okay, so let's now do that. Okay, so we're going to echo our alias build is going to move to the root of the workspace. All right, and then after that, it's going to run the colcon build command. So I'm going to pipe that alias over into the bash rc file. And then so that our terminal can recognize that new alias, I then am going to source the bash rc. So that single command does it all. It adds the alias called build to your bash rc file. Okay. And now anytime you want to build all the packages in your ROS2 workspace, all you need to do is type build. That's it, build. Makes it easier. I like to do that because you're going to be building code all the time. Now let's say you don't want to build all the packages on your system. You just want to build one package. To build a specific package, you would type colcon build, 2 hyphens, packages, select, ROS2, press the fundamentals, examples, just like that. So you do, the syntax is colcon build, 2 hyphens, packages, hyphen, select, and then the name of the package right here. That enables you to build just a single specific package. Then you press enter. Let's install some useful external packages that will help us along the way. If you don't have Terminator, install it now. Terminator lets you have multiple terminal windows open within a single interface. So we're going to do sudo apt-get update. Okay. Clear sudo apt-get upgrade. Clear. Now let's do sudo apt-get install Terminator. So to open Terminator, you can either click the ring right here, bottom of your desktop, search for Terminator. There it is right there. Or we could have just typed Terminator right there in the terminal. And Terminator is pretty cool because now you can right click and split horizontally and you have two terminal windows. You can also right click and do split vertically and you have one on the left and one on the right. I'm going to close that. And now let's install some useful packages. So the first thing you're going to do is type this command right here. All right, and I'm highlighting it. So it's sudo curl hyphen lowercase s, uppercase S, uppercase L, and then this https://raw.github/user-content.com /ROS distro /master/ROS.key space -o, which means output, and then a space, and then /usr/share /key rings /ROS archive keyring.gpg. So feel free to pause, type all that command, and press enter. Now, I've got another command for you. This one. Pause and type that command. Okay, and this gets the source list for the packages. Pause it right there. Make sure you get everything. And when you've typed that in, press enter. Now do a sudo apt update again. Let's clear so we can clear things out. Okay, and now we're going to install a bunch of packages. So now let's do one right after the next. Sudo apt-get install y, and we're going to type a bunch of packages, one right after the next. So the first one we're going to do is ROS $ROS _distro curly braces ROS Jazzy. Okay, so sudo apt-get install space -y space ROS $$ curly braces ROS _distro, all caps, and then close the curly brace right here, and then hyphen lowercase ROS Jazzy. Okay, it's already installed. All right. So we're going to install a lot of packages just like this. I'm going to copy and paste everything into the terminal. Yes, it's a lot. Take your time. Feel free to pause the video. You're going to install the ROS Jazzy package, the Jazzy ROS2 control, the Jazzy ROS2 control demos, the joint state publisher GUI, Move It, Shacro, ROS2 control, ROS2 controllers, and then the libserial dev package and Python 3 pip, which should already be installed, but it's just good to make sure it's in there. Pause the video, type all of that, and when you're done, press enter. And now it's going to install. Let it finish. It's a lot of software. And you won't install all of these software packages every time you create a package. You've seen how to create a package already. These are just some nice recommended pieces of software that we're going to use later. And that's it. You've gotten through the end of this tutorial on creating a ROS2 package. We've got a lot more in store for you. That's it for now. Thank you for watching. Keep building.